Hi, my name is Smitesh and welcome to Code with Smitesh. In this video, I will be talking about an advanced concept of C++. The topic name is template specialization. As the topic is belong to template, we will discuss first what is template. Then we will discuss what is template specialization. Then different type of template specialization and why should we use template specialization. So let's get start the video. Okay, so let's first discuss about what is template. Consider this code snippet. In this code, we have a two add method. One add method is accepting two integer parameters, while another add method is accepting double parameters, and both have the same implementation of the addition. In the main, we are calling this add method with respective argument. Now consider, in the future, if we have something new data type and we want to do the same addition operation, do we need to create one more add method for that data type? What happen for another methods like subtraction and multiplication? Do we need to really create individual method for each data type? That is a complex programming, right? So to overcome this, in C++, we have a concept called template. So what template is suggesting? Create only one generic method for all the data types. So let's read the definition of the template here. A template allows a generic function or a class that works on a different data types. That means we will create only one add method that support all the data types instead of writing individual add method for all the data types. Okay, so how can we create such template add method? So this is an example of the templated add method. So in this method, we are first declaring the template and that type name t. This is the actually replacement of the data type here t and add, and we are passing two template argument parameters, two template parameters num1 and num2 and perform the same addition operation. In the main, when we are calling add method, we are passing the appropriate data type and call the argument based on this data type. Okay, so here we can use this add method for all the data types. Now what happens if user pass add method with some inappropriate data type like this? Consider this add template add method here t num1 num2, this is the same that we earlier saw. Now here we are passing add character and we are passing the character argument 2 and 3. Should we really need to do addition operation for this character? What happen if user pass string also? This add method will work? This is a big question, right? So if we pass all these parameter, this can be work or this cannot be work. Or sometimes if we pass our user defined data type, it can crash also, right? This is just only the simple add method. What about if we have some complex implementation, like inside we are using any pointer or anything? That in that case, if we pass any data type to this kind of template method, it can throw an exception, it can uh, give the wrong value. So one template method cannot solve all the problem, right? In this case, we can see here, when we pass this character with 2 and 3, it will print e instead of 5. That means here we require some extra handling, some special handling, right, for this character data type. If we pass user add string, we need some special handling for this add method. And that is the only logic of the template specialization. That means, let's we first read the definition of template specialization. What is template specialization? When the default implementation does not suit all the type, we saw default implementation of the add for all the data type is not solving for the character. Okay, that means template specialization allows to define different implementation of the template of for a specific type. That means we need to provide one more add method for that particular character. character data types. If we are passing some string data type, then we have to handle something in different way for that add methods, and that is only called the template specialization. This is the same example that we saw earlier. Now how can we write this template specialization method? Here consider this is the template specialization logic. So here we have the this generic add method, here generic add template method, template type name t. This is exactly the same method here. Now this method, this character add, that works for the character data types. Okay, so here we are writing template, then plain this bracket character add. Here we are specializing. Here if you see, here specifically writing our special data type character, character num1, character num2, and we are doing addition operation basic using the ASCII character. So implementation can be changed. Here if you see different implementation, here we have different implementation than this one. Okay, so this will handle the character argument, character data type, this template add method. Similarly, if user pass string, here with the string we have some different implementation. If you see here, this is string template specialization, template string add, and here we are specializing with the string as str1, str2, and concatenating these two string. Here logic can be anything, it is up to your requirement. If you are writing your template specialization method, this logic you should know, but we cannot use here if our generic template method will not support for all the data type, and we want some special implementation of particular special data type, we can use this template specialization and provide our own logic. So here when we pass here add character 2 and 3, it will come here, it will perform this operation and show the result. Here it will give the 5, 2 plus 3, just we are doing ASCII character addition and subtraction, here ASCII character implementation logic. Similarly, if we pass string modern C++, here we are just doing concatenation. So this is the logic of the template specialization. That means one more time we can understand the same thing. When the default implementation, when the default template implementation does not suit all the type, here this is the default template implementation, it is not suit for character and string data type. Okay, correct? That means for that one, template specialization allows to define different implementation of the template for specific type. That means for the character and string, we can use the logic of template specialization and provide our own implementation for the character and string data type. That is only called the template specialization. Now we see different type of template specialization. There are two type of template specialization. One is full template specialization and one is partial template specialization. What is full template specialization? So full template specialization defines a complete implementation of a template for a specific type. That means if I am writing for the character data type, so whole that template add method will perform the character data type. It specializes for the character data type. If I have the mixed match of data type, then that is only for the that data type, for example string and character. So that complete template method work for the string and character data type. For that class we are specializing full templates. I will show you the same example in the next slide. Now what is template specialization? Template specialization means if you see this class, here I am using template class. So this one method is templated, generic method, but another is specialized. That means consider if I have an integer, then user can pass integer, but if I have a string, then user can pass integer to string, then double to string, but this is specific string only. That is because half of the parameter are specialized, not full the parameter. Here full parameter is the specialized, here half of the parameters are specialized. Let's see the example for the full template specialization, we have the same addition example. Here we can see, here we are specializing for the full parameters, character and character, string and string. This is the same example that we show earlier. One more time we will read this definition. Full template specialization example. The full template specialization defines a complete implementation of a template for a specific data type. Here we are defining complete implementation. I hope you get it. Let's discuss about the partial template specialization. Partial template specialization allows for some template parameter to be specific while leaving other generic. That means one of the parameter can be specialized while other can be generic. Consider this class product. T is a key and U is a value. Both are T and U are template type, T and U. Here this is a constructor and we are doing list initializer here, key and value, and this is a simple print display method that display this key and value. This is a generic template example, generic template class. Now this is a partial template specialization. If you see here, we have only template, one single template, U, while in the class product, here we have a T and U, here we have a specific. If you see here, string is specific, that is fixed, and U is a variable. U can be integer, U can be double, U can be anything. Okay, so here string key, U is a value, and the same, if you see, both are the same display method. In the main, when we use integer and string, it will call this method, because here the first parameter here is integer, here come, and string is the here it will come, and 1001 mango, so it will print 1001 and mango. While in the second object, print product string, if you see here we are passing string, that means here it is matching. If you see product with product string, and this is variable U and this is generic, right? Double here, you can use here integer also, you can use here float also, you can use even string also, and initialize with the object mango, and this double parameter, that means any value, price here, mango's price, and display, so it will display a mango and its price. So this is the example of the partial template specialization, where we have some of the parameter are specialized while others are can be generic. Now why should we use template specialization? So first reason is template specialization provide custom behaviors for specific data type. That means if we see our generic template, we saw, right, our generic add method is not supporting for all the data types. So that means we can provide specific special method for the specific data type. That means we can provide the custom behavior. We will have a custom add method that handle a specific data type. Consider in that add method, if I am passing two product addition, this is a imaginary example, two product addition, so I can use addition logic of that two product in this add method, in the add method. That means I can provide the custom behavior for the product data type. Another reason is performance optimization. Consider you are writing any sorting example. Okay, this is an example just I am giving you. If you are writing templated sorting example, it is working for all the data types very well, but for one data type it is not properly working. So in this case, you can use this template specialization logic for that particular data type and change the implementation based on the good performance. That means template specialization also handle performance optimization for a particular data type. Another is handling edge cases. That means we saw the same add method. it was not supporting character and string, but we handle such edge cases using template specialization. So these three reason uh, we should use the template specialization. If in our project we come across such kind of requirement, we at least try to see the template specialization and use it. So let's see in the code whatever we discuss into the presentation. So here I will be using the same add method example. So this is a add method, integer add method that accept two integer parameter, and another add method that accept double parameter. And in the main we are calling this with the integer argument and with the double argument. And when we run, it's give us the same 30 and 78.1 the respective output, addition output. Okay, now we will use template instead of individual method. So I have already written the code to save the time. So let comment this code and go down and uncomment the templated code. If you see here, this is a generic template method. Okay, and that accept two template argument num1 and num2 do addition, and we in the main we are calling this add method with the integer and double parameter. Okay, so let's build this code and run it. It is not refreshing. Yeah, if you see, it is giving the same 30 78.1 output. Now when we pass this character, okay, it will give wrong output. Let's see here, this add generic add method is not supporting to the character. Now here 101 instead of 2 plus 3 5, it displaying 101. Okay, so here this generic add method is failing, and to overcome this we can write template specialization method to support this character data type. Okay, so the code has been already written, so we will use that code. uh, Here this is a template specific code, template specialization code. I explain you the code. So if you see here, we have a generic add method that accept two num1 and num2 parameter, and we are performing addition operation. Here this is a template specialization for character. If you see add character, here it is a specialized method for character data type. Then we here we are doing our own addition implementation. Okay, similarly when user pass string data type, so we are here handling string data type also. So this is template specialization for the string data type. So my logic is here to just add means concatenating two string. So string 1 plus string 2. Here I am giving space, and it is accepting string 1 and string 2 parameter. Okay, string, both are string data type. And in the main, the same add integer, add double, and add with the character 2 and 3 that we saw earlier, and calling add string this data type modern C++. And this implementation, this add, when its method execute, it comes here and perform this operation. When we pass string data type, it comes here and perform this operation. That means here modern, then space and C++. Let's build this and run this. Let me again run. Yeah, it is in another window. We can see here 30, 78, then 5, 2 plus 3 here, and modern C++ here. So we saw the template specialization method here. This is also called the full template specialization because here both we are doing specialization for both the parameter. We will have one more example for the partial template specialization. Let's see that example. Let me uncomment this code. Now, sorry, uncomment this one, and previous one it was commented. Okay, so here we have a template class. This is an example of partial template specialization. Okay, so here we have a template and we have a two template parameters, t and u, two template definition, t and u, and we are defining class product t, this t with key variable and this u with value variable, key and value. Assume this is just imaginary class for this example, and this is a constructor where we will user pass two argument, and here we are capturing that argument with the t, small t and u, and here we are using the initialization of this key and value member variable, and we have one more add method display that display this key and value. If you see here, key and value, and this is a generic template because if you see here all the parameters are generic, t and u. Okay, now in the main, when we pass integer string 1001 and mango, so it will come here in this class. It create the object of this class. Here integer and string, it will come here, and when user call this object obj1 display, it display this method. Now this is a partial template class example. This was a generic one. The same here, product. Consider this is a string. This is a fixed data type, right? String, and this is a generic. So here, because here one of the parameter is generic, this is called the partial template specialization. This is a specialization for the string data type for this product class. So we have a string product key, string key, and u is the value. So when user create object using string and any of the, because this is generic, right, string integer, then also it comes here. The first argument must be the string to run this instantiation. So string double, and when we call this object method or object to display method, it will display this partial class template. Let me run again, build first. Okay, I need to close this. Yeah, clean, and I am building. So this is my output of the example. If you see here 1001 passed and mango, so this is using a generic class example because this is a full generic object, full generic class object, generic template class object here, while the below one, this is a string, and because this is matching with here string, this will the partial class object mango and 20.50. I hope you understand the logic of this template specialization and different type of template specialization. If you like this video, please share, subscribe my channel. Thank you.